Hello everyone, I hope you all are doing great. So today we'll be looking into the nomenclature of the alkane that would include both of the systems, common naming system and the IUPAC system. Now, when you're coming at the point where you have to do both of the systems nomenclature, so keep in mind that widely the IUPAC system is considered. We are only studying the common name system for creating a conceptual basic of the of a person, of a student. But usually, whenever we are talking about the nomenclature, so widely internationally, the IUPAC system is considered. So very first, we will be looking into the common naming system. First, what is alkane? Alkane is a compound that contains the single bonding of the carbon compounds, the hydrocarbons. Now, very first, when you are talking about the single bonded hydrocarbons, you must be known about the homologous series, the methane, ethane, and if you haven't known about it, there is table on this page. Here you can view it. This is the prefixes that are being used, and here you can see the alkanes. So it is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, and dodecane. Now undecane and dodecane is usually not considered since we do have the nomenclature till 10, so we'll only consider things till 10, and it will went like this. Let's get back to the point. Now, just suppose for a while you are given a situation where there is a bond between carbon and carbon. And very first, you must be known that carbon and carbon have the valency. Carbon has the valency of 4. So here, first valency is considered as the bonding between the carbon-carbon, and then all 3 leptons will be considered as the bonding between the H3. So there will be bonding between H3 and H3. Now, combinedly, if you look into the situation, keep in mind, now this situation is basically the situation of eth. First, we'll write the eth. Then, look into the situation that is there any double bond, is there any single bond, or is there any triple bond? So here, the single bond is taking place. So we'll simply write the ane. That showcases that this is a single bond system. So this would be what this would be the ethane. This is the formation of the ethane. Let's move on. The second example. Okay, this was the nomenclature according to the common name as well as the IUPAC name. Since in the common name, what you usually do is add on a n prefix. Now, what is n? There will be 3 terminologies that will be used in the common name system: N, neo, and iso. At very first, N is considered to be the terminology for the single branch, non-branch chain. There won't be any branch in the N chain. Whenever there isn't any branch, we'll simply add the N in the starting of the nomenclature. So it would be N-ethane. Okay, then it comes iso. Iso means whenever there is one branch in the whole parent shell, so this is known as the iso system. Or if there is a situation where the carbon, 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 and carbon, now there is a branch here and there is a branch here, again this would be considered as the iso what 1 2 3 4 5 iso pentane. Why? Because we are having a situation where there isn't the formation of the single branch chain, a single chain. So this won't be the n chain, but this would be the iso chain. Now what is the neo? Neo is a situation where the carbon is having the all 4 bondings. Just suppose for a while this is the situation where the carbon is attached with all 4 carbons. So this would be considered as the neo. Now what will be the nomenclature of this situation if we aren't considering this? So it would be the neopentane. I hope that you get it, the concept of the N, iso, and neo. Now let's move on. Just suppose for a while that you are given a situation where there is carbon, 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 and carbon, and again a carbon. Now in this situation, if I'm adding a carbon here and a carbon here, and since I have mentioned before in my previous videos that in the common naming system we were having the limited resources to name the organic compounds. That's why we introduced the IUPAC system. So whenever you are talking about the ISO system, so always keep in mind that the ISO branch will be attached on the second last chain, second last or first second part of the chain, like either at this second part, either this second part, none other than this. So here the situation is, first, name it according to the numbering. 1, 2, 3, 4, 5, 6. Again, we do have carbon here and a carbon here. So whenever we are doing the nomenclature in the common naming system, we'll consider these as well. So it will be 7 and 8. Combinedly, these all will create an octane. An oct. Let's first write the oct. Then it comes that, is it in carbon? Is there any carbon that is attached by the 4 carbons? No. So there will be nomenclature of the iso. Iso. Then it comes on which point this is becoming iso. So at first it is being considered as iso at the second point and at the fifth point. So we'll simply write iso 2 5 oct. Then we do have a situation where it is having the single bond, so we'll simply write it as ane. Iso 4, sorry, yeah, 2 5 octane. This is how we'll name these things. Now let's move on to the third part, that is of neo for sure. Just suppose for a while you're given a situation 1 2 3 4 5, and here there are 2 carbons attached. And okay, let's just first name this. So in this situation, this carbon is attached by 4 carbons more. So we'll simply write neo. This is the isomer of the 1 2 3 4 5. This is the isomer of the hexane. No, hexane, no. It is the isomer of the heptane. So here it will be neo. Then this is combinedly and hapt. How? If you count the carbons, so it was 1 2 3 4 5 6 7 8. Okay, my mistake. It isn't the hapt. It is actually the oct. So this would be oct. Now on which branch it is attached? Now at very first, whenever the neo is attached in a situation where this is attached with the carbon at the end, so we don't need to consider writing that it is attached on the second, it is attached on the fifth, it is attached on the sixth. We'll simply write oct and then ane, neo-octane. If you want to write one, you can write. So this is how we name the nomenclature at the common naming system. Now let's move on to the IUPAC system. IUPAC system is way easier than the common naming system. At very first, consider a situation where you are giving this sort of figure. Now at very first, what you'll do, you'll make a parent chain. The parent chain should be a chain with the most of the carbons. At very first, if we'll consider this as the parent chain, how many carbons are there? 1 2 3 4 5. If we'll consider this as the parent chain, so there are 1 2 3 4 and 5, same number of the carbon. So let's just consider simply this one as the parent chain, just to make the situation more easier. Now consider writing the numbers from the situation from the side from where the branch chain is there. So we'll write it from here, 4 and 5. Now at what point the carbon branch is attached. Now at the second point carbon branch is attached, so we'll write 2. And then what is this? This is a methyl. Since a carbon has the valency of 4, so we'll directly consider it as the methyl. So we'll write methyl. And then it comes the parent chain nomenclature. So the parent chain is of pentane, so we'll write pent. And then this is a single bond system, so we'll write pentane. So this is how we name in the IUPAC system. Now, for a while, consider a situation where there is again a carbon attached here as well. Let me remove this one. Let's consider, I only write the carbon, consider the hydrogen bonding by yourself. Very first, start naming from the situation where the hydrogen, not the hydrogen, the carbon branch chain is near. So in the both of the situation, carbon chain would be on the second number. So we'll simply write the situation. We'll simply name it 1, 2, 3, 4, and 5. Now first count down the number from where the branch chain is attached. So it is on 2 and 4. Again, there are 2 methyl branch chain attached. Both of the situation, there is a methyl. So we'll write di. If there are 3 branch chain, then you have to write the tri. But in the situation we have 2 methyl, so we'll write dimethyl. Please compensate on my writing system. Well, we'll now write the total branch chain, total straight chain nomenclature, that is pentane. So this would be the nomenclature of this. Now let's make it more complex. Okay. Let's have again one more carbon here and a methyl here. In this situation, first consider the longest branch chain. If we write the name from here, 1, 2, 3, 4, 5, and 6, is it a branch that is more longer? Yes, it is. Hence, we are having 6 carbons attached in this situation if we consider this as the parent chain. And we will be having 5 if we consider this one. So we have considered this as the parent chain. Then it comes to count down the methyl. So first, we will be start naming it from here since the branch chain is nearer. So here it will be 2, comma 2, since there are 2 different methyl. Then it comes on what number this carbon is, a methyl branch is attached. It is on the 4th number, so we'll write tri and then methyl. And then what is the homologous series prefix for the 6? It is hex. So we'll write hex, and then it is single bond, so we'll write ane, hexane. This is how we name the nomenclature of the alkanes. I hope that you get it, and thank you so much for watching our video. So this is a straight 14 minutes video. Hope that you get it. Thank you so much for watching.